Greetings, my viewers. My name is Putri Meidy Maharani. I'm from Udayana University, and today I will be presenting about tensile tests. So, before I start, let me just refresh and review what is stress and strain curve. So, stress is y-axis and strain is x-axis. This is the specimen. You can plot of the end and you pull it apart. So as you pull it apart, the specimen elongated and it extended, and we measure the delta L. The delta L is elongation and stress is a load being applied to the specimen. So what we will get from this is a load and elongation curve, and then from there you can convert that graph into the stress strain curve using the formulas. Next, the specimen preparation. We will first need to prepare our specimen. So what is this? The specimen. This is the for this we will using the aluminum AS6061. Has a length of 150 millimeters. L1 and L2 is 14 millimeters. And what we do here, we make a shoulder of the concentrated beyond the elongation, and that's where the neck will be appeared, and that where the fracture would happen. So what you do is you first have to draw what your specimen one look like, and then you just grind off the materials so that it look like this. The R is supposed to be 12.5. However, due to human errors, it's not very uniform, but that's okay. Next, instrument. And here this instrument that we will be using, and here right down is hydraulic jack. What it does is push this inner square, location the specimen, and this right here, and this right here is micrometer gauge. What it does, track the elongation what we apply to the specimen. And we have the digital weighing scale. So this read the load that we applying to our specimen. However, this is in kilogram. So right there in the middle, we have our specimen claim using wedge grip. So what you do now is you extend the hydraulic jack so that this inner square will go up and force our specimen into elongation until eventually fracture. While we do that, we would have to take a note of the displacement here and load being applied. And this data we got from the specimen number 1. As you can see, here is not perfect as the graph we saw at the first before, because this was done with hydraulic jack and clamp using non-conventional clamps, So you can probably tell this what probably happened. Here is the specimen. The specimen slipping from the claim, making giving of the either more load or more elongation. It really depends. So my hypothesis is the claim are slipping form of the specimen. That's why we're not given such a clean cap, but more or less is quite presentable. So you can see here this probably the elastic region, and right here sort of start moving into the plastic region, and then eventually fracture right under 300 Newton per millimeter square. And next we have specimen number 2. Not that different of story, also not be the best graph. You can see you will find around, but this is also quite presentable. This is the elastic region, and then this is where start become plastic region, and then it will fracture at 327. And this the specimen number 3. Here you can sort of see elastic region, and then here the plastic region, and here's ultimate tensile strength, and probably where the neck start to simply fracture. There's a 326 Newton per millimeter square. So that's all I have for today, and thank you for watching.